Let's solve these two problems based on the concepts what we have learned. Okay, look at the first one. See, the first one says, show that the relation R in capital letter R defined as R is equal to A comma B such that A less than or equal to B. So this is a very important condition. See this, A less than or equal to B is reflexive and transitive but not symmetric. So you all know what is reflexive, transitive and symmetric, correct? So we'll start with the value. Now how do we do? Suppose we are defining R is equal to A comma B such that A is less than or equal to B, correct? Now for reflexive, so what we'll do, we'll start with reflexive. See, if it has to be reflexive, then for all A comma A should belong to capital letter A, right? This is the condition for the relation to be reflexive. So in this case, we need to take A comma A, isn't it? So now what do we have? Now if you take A belonging to A, then A comma A should also belong to the relation R. Sorry, relation R, correct? This is what we mean by reflexive. So in this case, so what do we have? A comma B is nothing but A less than or equal to B. This is the relation, isn't it? So if you have A comma A, then A is less than or equal to A. There is a equal to sign. That means we have A is equal to A, isn't it? So for all A belonging to A comma A belongs to R, correct? So how we write it? For all A belonging to A comma A belongs to R. Therefore, R is reflexive. R is reflexive. So one part is done. So what did we prove? We proved that it is reflexive. Now we'll go for the transitive part. All right. Now what do we have? For the transitive part, so for transitive. Now transitive is what? If you have A comma B and B comma C also if you have, then A comma C should be there, isn't it? This is what we mean by transitive. So in this case, what do we have? You have A less than or equal to B. This is where we have A comma B. So when you have A comma B and B comma C, then you should have A comma C. This is basically transitive. So A less than or equal to B, first part, and B less than or equal to C. See, if A is less than or equal to B and B is less than or equal to C, now when you combine them, can we write A less than or equal to B less than or equal to C, correct? So what can we imply from this? We can imply that A is less than or equal to C, isn't it? Because A is less than or equal to B, B less than or equal to C, so A less than or equal to C. So this implies A less than or equal to C, which is nothing but A comma C belongs to R, isn't it? So what did we prove? For all A comma B, sorry, for all A, B and C, A comma B and B comma C belongs to R, then A comma C belongs to R. So what can we say? Therefore, R is transitive. Now we need to do the symmetric part. All right. For the symmetric now, symmetric is what? If you have A comma B, then you also need to have B comma A, isn't it? This is basically symmetric. So when you have A comma B, that is A less than or equal to B. If we need to have B comma A, that is B less than or equal to A. See here, if A is less than B, can B be less than A? Is it possible? equal to? Yes. But is it possible that it is one is less and one more is greater? It's never possible, isn't it? That means if A is less than B, then B is never less than A. It's always greater than, correct? That means B comma A does not belong to R, correct? So what do we say? A comma B belongs to R, but B comma A does not belong to R. Since B comma A does not belong to R, this implies R is not symmetric. R is not symmetric. This is basically the first question answer. So we proved that it is reflexive, transitive, but it is not symmetric. Fair enough? Now let's do the second question. See, for the second question now, check whether the relation R defined in the set 1, 2, 3, 4, 5, 6 as R is equal to A comma B such that B is equal to A plus 1. So we need to show that, okay, we need to check whether it is reflexive, symmetric or transitive, correct? Now what do we have? R is equal to A comma B such that B is equal to A plus 1, correct? Now my set is what? So we can say set is A, which is 1, 2, 3, 4, 5 and 6. This is the set, correct? Now whatever values we are going to get has to be within this particular set, correct? This is what we mean by being reflexive, symmetric, transitive, whatever is based on A. So now what do we have? We have A comma B. So first we'll start with reflexive. Reflexive. Now for a reflexive relation, A comma A should belong to R for all A belonging to A, right? So we have A comma A. So for all A belonging to A comma A should belong to R, correct? This is what we mean by being reflexive. So in this case, when we have A comma A, this is nothing but A is equal to A plus 1, isn't it? So when we have A is equal to A plus 1, so we can say, we can cancel off the A value. That means we can say that 0 is equal to 1. Is it possible? Is it possible to have 0 is equal to 1? Never, right? So that means what can we say? This implies that A comma A does not belong to R. Therefore, R is not reflexive. R is not reflexive. Fair enough? Now we'll go for the symmetric one, symmetric relation. Now for symmetric relation, what do we have? If A comma B belongs to R, then B comma A should also belong to R, correct? This is what we mean by transitive, sorry, symmetric. In this case, A comma B is nothing but B is equal to A plus 1, correct? B is equal to A plus 1. Next, what do we have? The second relation is B comma A. That means A is equal to B plus 1, correct? Let's look at it. So here B is equal to A plus 1. Here we'll get A is equal to B plus 1. So for all the values, because see, we have the set as 1, 2, 3, 4, 5, 6, isn't it? Now, will the set of all the numbers, will it be there or not? We need to check. Some of them do exist, obviously. That means, for example, I can say that 2 comma 3 will exist. But 3 comma 2, will that exist? This is what we are looking at. Understood? So in this case, B is equal to A plus 1. Here A is equal to B plus 1, correct? If you substitute, B is equal to B plus 1 plus 1, correct? B and B cancels. So I'm getting 0 is equal to 2. Guys, obviously not possible, isn't it? So since this is not possible, that means A comma B belongs to R, or for all A comma B belongs to R, B comma A does not belong to R. I can give you an example. Like say 2 comma 3. But will 3 comma 2 exist? No. Because 3 comma 2 can never occur. Because if 3 comma 2, I cannot say 2 is equal to 3 plus 1, isn't it? It's not possible. So A comma B belongs to R, B comma A does not belong to R. So what can we say from this? Therefore, R is not symmetric. R is not symmetric. Now we'll go for the transitive, the last part, and we're gonna check it. Alright. Transitive. See, what do we have for transitive? If A comma B and B comma C belongs to R, then A comma C belongs to R, isn't it? This is what we mean by transitive. So we'll start with this one. Okay, now A comma B. So we have B is equal to A plus 1. C is equal to B plus 1. Okay, we'll look into this one. Now what do? We substitute. So when we substitute, C is equal to, so in place of A, what can you write? Sorry, in place of B, what can you write? A plus 1, correct? A plus 1 plus 1. So C is equal to A plus 2. Now tell me, is this how we define a relation? The relationship is B is equal to A plus 1. That means if you had, again I'm telling you, if you had A comma C, then wouldn't the relation be C is equal to A plus 1 and not A plus 2? Correct? That means A comma B belongs to R. B comma C belongs to R. But is A comma C, does that belong to R? No, right? Because if that was a part of the relation R, then we would have got C is equal to A plus 1. But what are we getting? C is equal to A plus 2. Correct? Now, to think of an example like this one, maybe you can say 3 comma 4, sorry, 3 comma 4 and maybe 4 comma 5. But 3 comma 5 that is not going to be a part of the relationship, isn't it? So here what do we have? A comma B and B comma C belong to R. But A comma C, this does not belong to R. Therefore, R is not transitive. So what did we get in this one? So R is neither symmetric nor reflexive nor transitive. So when they say check, you have to check in this way. Clear? So these are two simple problems based on the relation, different types of relation. In the next video, we'll see few more types of problems and few more problems also.